Good morning, my dear students. Let us start today's class with a small problem. We are studying our 12th chapter, electricity. Yesterday we completed till ammeter. Okay, we studied current flow through a conductor and ammeter. So we are going to solve one problem. Okay, I'll read out. A current of 0.5 ampere is drawn by a filament of electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. Okay, and I'll write the solutions here. Solution. Let us check what is the solution. Which are given current I is equal to 0.5 ampere and time is equal to 10 minutes. It is generated using, if we have to convert it into second. So it is 10 into 60, that is 600 second. So what we want to find? Electric charge. That means Q we want to find. Already we have the solution. We have the formula I is equal to Q by T. So Q is equal to I T. Is it correct? Q is equal to I T. So Q is equal to, what is I here? 0.5 and T 600 second. That time it will become 300 Coulomb. 300 Coulomb. Okay. Just see the solution. Which are given? Current I is given, which is 0.5 ampere. T is given 10 minutes, that is 10 into 60. We have to convert it into seconds. This is in minute. We want to convert it into second. So we are knowing the formula. Current I is equal to Q by T. So we want to find what we want to find. We want to find the electric charge, that is Q. Q is equal to I into T. Okay. So Q is equal to 0.5 I and T 600 second is T, and we got the answer 300 Coulomb. Then there is 3 questions. Let us check the answers for the 3 questions. What does an electric circuit mean? What does an electric circuit mean? We already studied that a continuous closed path of electric current, or we can say path for transmitting electricity. You can say path for transmitting electricity. Okay. Path for transmitting electricity, and it should contain a device for generating energy or electricity. Okay, it should contain a device to generate electricity or energy, such as cell, battery, or anything. Okay, so define the unit of current. What is the unit of current? The unit of current is ampere. Unit of current is ampere. Unit of current is ampere. Then calculate the number of electrons constituting 1 Coulomb of charge. Calculate the number of electrons constituting 1 Coulomb of charge. One electron possesses a charge of 1.1 electron. One electron possesses a charge of 1.6 into 10 raised to minus 19. 1.6 into 10 raised to minus 19 coulomb. Okay, one electron possesses this much of charge. That is equal to 6 into 1018. 6 into 1018 electrons. 10 electrons possess 1 coulomb charge. For one electron, this much coulomb is 1.6 into 10 raised to 19 coulomb is the charge. And what is our question? The number of electrons constituting 1 coulomb of charge. So for 1 coulomb of charge, this much 6 into 1018 electrons possess 1 coulomb of charge. Okay, 1 coulomb for 1 coulomb of charge, 6 into 1018 electrons are needed. Okay, to possess 1 coulomb of charge. Okay, and how do a metal conduct electricity? How do a metal conduct electricity? How do a metal conduct electricity? That we are going to study. We know that electrons are conducting electricity. We will think that how the energy, the charge of the electron is too low, and how this low charged electrons move in a tightly packed, or the space, little bit space is there. You know, the packing of electron, the packing of atoms in a solid. So, how a small charged electron moves in this tightly or closely packed solid. But actually, it is more as smooth as moving in a vacuum. Okay, it moves as moving in a vacuum. The moving of electrons in space is different from that of other charges. Okay, it is having a different movement. When a steady current is applied through a conductor, it moves in drift speed. It moves with a average drift speed. Okay, the electrons moves with a average drift speed. And when a small current, we are considering copper wire. Mostly we are using copper wire. If we are considering copper wire, if a small current is there, the drift speed will be very small. Okay, drift speed will be very small in small current. Okay, the drift speed will be small in small current. Then one more question: how does an electric bulb glows? How does an electric bulb glows? Yes, we are discussing about how does an electric bulb immediately glows when the switch is on. So let us see. Here one terminal is there, and here I have placed one switch, and the second terminal is there. And when the switch is on, immediately the bulb glows in terminal. This is terminal 1 and this is terminal 2 where the bulb is there, and bulb glows. Okay. Suddenly it glows. Do you think that physically this current reaches from here to there? Because we studied that the physical drift of electrons is a slow process. So it will happen in a lightning fast. You see, if you on the switch, suddenly the light ons. So it is a lightning fast process. So the actual mechanism of this is very fast. With the help of electrons it is happening. We will study further more, okay, in our coming lessons. Okay, so we are moving to our next portion, which is electric potential and potential difference. Okay, we are going to deal with electric potential and potential difference. So electric potential and potential difference. What makes an electric charge to flow? If we consider a copper wire, it won't flow simply. Just like you see horizontally, like this, one pipe is there, horizontal pipe is there. Whether the water will flow through it, it is perfectly horizontal, means just the water flows through it without pressure. It is not possible. Or else, in one case, the one end of the pipe is kept in this height and the other end is kept in this height. What will happen? A pressure is there, the water will flow to the down. Yes or no? It will flow from the higher end to the lower end of the tube. For the flow of current or charge in a metallic wire, like what in this case, in the case of water, there should be a pressure between two ends. Okay, gravity is not having any role here, but if there is only like the water moving in this pipe, the electrons will flow only when there is a pressure inside, or pressure is there. A pressure is there. Okay, this if there is a pressure difference between 2 points is there, and this pressure difference is called potential difference. Okay, so once again, here if it is a perfectly horizontal pipe, this without any pressure the water won't flow. But in this case, you consider this as also a pipe, and if from here the water will smoothly flow towards the down, okay, the end A to B. Like that, in the case of electric charge also, some pressure is required for the flow of electric current. Okay, That is called potential difference. And the potential difference can be produced by a battery consisting one or more cells. Okay, we can for the flow of electric current, flow of charge, we can add a battery consisting of one or two or three, how many cells, okay, many cells, to produce a potential difference. Then if the potential difference is there, the charge will flow. Then we are going to study about potential difference between 2 points. Potential difference between 2 points. Potential difference between 2 points. How we will define this? It can be defined as the work done to move a unit of charge from one point to another. Potential difference between 2 points can be defined as the work done to move a unit charge from one point to another. The work done to move a unit charge from one point to another. Okay. So, how we can represent potential difference between 2 points? V is equal to work done W, and work done W and by charge. Okay, by charge Q. Okay, so we can say V is equal to W by Q, where W is work done and Q is charge. The work potential difference between 2 points, V, is the work done to move a charge from one place to another. So we can say V is equal to W by Q. So the SI unit of electric potential is volt. Okay, the SI unit of electric potential is V. Okay, SI unit of potential difference is V, and is named as the Italian physicist Alessandro Volta. It is named as the Italian physicist Alessandro Volta. Then let us see how we can define 1 volt. Okay, how we can define 1 volt. How we can define 1 volt? 1 volt. Okay, 1 volt. 1 volt is the potential difference between 2 points. Okay, 1 volt is the potential difference between 2 points. Potential difference between 2 points. When 1 joule of work is done, 1 volt is the potential difference between 2 points when 1 joule of work done to move a charge. To move a charge. Okay. 1 joule of work done to move a charge of 1 coulomb. From one point to other. Okay, what is 1 volt? 1 volt is the potential difference between 2 points. That is, when 1 joule work done to move a charge of 1 coulomb from one point to another. Okay. When 1 joule work done to move a charge of 1 coulomb from one point to another. And did you heard about voltmeter? Yesterday we studied about ammeter. Today we are just studying about voltmeter. Voltmeter. After hearing the name voltmeter, we can understand it is a device used to measure the device used to measure the potential difference. Measure the potential difference. Measure the potential difference. Okay. Voltmeter is used to measure the potential difference, and it is connected. Ammeter is connected in series, and this voltmeter is connected in parallel. In parallel to the points where in which we have to find the potential difference. And this is all for today. So I think everything is clear till here. And potential difference is the pressure needed for electric charge to flow in a copper wire or metallic wire. Okay, that's all. Or simply we can say like that. Okay, thank you.